Okay, so environmental quality, outcome 2, part 2, looking at topic 4, how much is too much. So a pollutant is any form of energy that will cause harm to a living thing. So some pollutants that we've already looked at is DDT, carbon dioxide, nitrogen oxides, sulfur oxides. These ones cause acid precipitation. This one, biomagnification. This one causes global warming. And so pollution is any alteration of the environment producing a condition that's harmful. So DDT is the pollutant, biomagnification is a pollution. Sulfur oxide and nitrogen oxide are the pollutants. Acid precipitation is the effect, that is the pollution. Carbon dioxide is the pollutant. Global warming is the pollution, right? So pollutants cause pollution. So now, when does this become a problem? Is it when it kills, or only when it makes it people ill, or is it when other organisms get ill? And do we start worrying about it when it's a global problem, or do we worry about when it's a local problem? How do we detect it? It's really hard to pinpoint what to do and when to get involved, but we're going to try and see if we can narrow that down. So there is a lab that you're going to do where you make serial dilutions. That is, you make each chemical 10 times weaker as you go through. We do it with salt, and then we do a taste test. Okay, and so one way of indicating concentration is percentage weight by volume. So like 1% milk fat has 1 gram of fat in 100 grams total. If you want 10 grams in 1,000. So what you're going to use are your simple math skills to do this. You've also seen in grade 8 the units of parts per million and ppb, parts per billion. pt would be parts per trillion. These are used to measure really small quantities, yet these small concentrations are big enough to be toxic. And by the way, just so you realize, 1 part per million is bigger than 1 part per billion, which is also bigger than 1 part per trillion. So 1 part in a trillion, right, is obviously smaller than 1 part in a billion. Here are some calculations that you need to be able to do. So to go from parts per million to parts per billion, there's a factor of 1,000. So here, 3 parts per million would be 3,000 parts per billion. And 175 parts per billion to parts per million, you move the decimal the other way, will be 0.175 parts per million. To calculate this, you go milligrams divided by kilograms or milligrams divided by liters. So for example here, if there's 5 parts in a million, how many parts in 1 million? So 5 parts in 1 million. I really wish I had access to my room to do this video, but okay, fair enough. 5 parts in 1 million equals x over 6 million. Right, and then to solve for x like you do in math, you just have to cross multiply. So x equals 5 times 6 divided by 1. That gives you 30 parts. So there's 30 parts in 6 million if there's 5 parts in 1 million. So here you go, 14% milk fat. How many grams of fat are present in a 500-gram container? So we have 14 grams and 100 equals question mark over 500. So to solve for question mark, you have to cross multiply, right? So it's 14 times 500 divided by 100 to give you 70. Or you can know 14% means it's 14 out of 100, so that's 0.14. Of means multiply times 500. In both cases, you're going to end up with the answer being 70. And then here we go. Here's the part per million. There's 7 milligrams and 125 grams. So remember, this could be milligrams per kilogram or milligrams per liter. In this case, we're going to go milligrams divided by kilograms. And so here we see milligrams divided by kilograms. There's 7 milligrams in 0.125 kilograms. So divide it, and that gives you an answer of 56 parts per million. Okay, so here's test your knowledge. Change this into parts per million. So it's going to be milligrams divided by kilograms. So we'll go 17 milligrams divided by 0.5 kilograms. You have to do a metric conversion. By the way, just so you're aware, you are not responsible for metric conversions on your PAT at the end of the year. Okay, but it's a good skill to have anyway. So the answer comes out to be 34 parts per million. 2% milk, how much fat is there in 250 grams? So that would be 0, set up a ratio, or 0.02 times 250. The answer turns out to be 5 grams. This last question is kind of funny. Change 11 milligrams in 1 kilogram of air to ppm. It already is. Milligrams divided by kilograms, so it's 11 divided by 1, so that is 11 parts per million right off the start. You just have to change the unit to say parts per million. Okay, and then there's a worksheet that you'll be doing for marks. There's also that lab that I talked about that you'll do. And now let's look at phosphates, nitrates, oxygen, and carbon dioxide identification tests. Okay, and so phosphates promote plant growth. They occur naturally. We know that also it used to be found in detergent. Nitrate is usually a sign of decomposition. We also know that it affects the leaves, but whenever there's decomposition, there is nitrates are there as well. Okay, and so this one here, you probably have a star beside it. You're supposed to know this one. Excessive phosphates causes algae overgrowth, and then so algae overgrowth is very important. And then the algae dies over time, and the decomposition uses up the rest of the oxygen level. So that's bacteria usually doing the decomposition. Okay, and that question shows up quite often on my quizzes. It shows up on the unit test. It shows up on the final exam quite often. How high phosphates and nitrates lead to low oxygen level. Okay, so literally, it fertilizes the water, makes the algae overgrow, makes weeds overgrow too, but mostly algae. And then when the algae dies and starts to decompose, the bacteria use up the rest of the oxygen. The test for phosphate that we'll do in the lab, magnesium sulfate forms a precipitate when it reacts with it, so it goes cloudy if phosphate is there, and I will have those labs set up for you to do. The test for nitrate, we're not going to do. There's something. Oh, and by the way, you don't need to spend any time memorizing these kits. It's not necessary. You'll never show up on a test or quiz. It'll never show up on the final exam. It's just good that you know what the actual tests are, because we are scientists. We do tests. The test for nitrate, there's a Lamotte kit, and you can compare the colors to find the part per million of nitrogen. It's kind of like that pH one. Except it takes longer for it to run, and so we typically can't get it done in one class. At least I can't, and so we're not going to do it. Plus, it's kind of expensive, so we'll leave that one alone. Oxygen is a really important element required by most life. High levels of oxygen usually indicates good water quality. So how do we get oxygen into water? Well, plants could put oxygen into water, and and of course, if the water is rough, like white water, when the water jumps up and crashes down over rocks, it puts oxygen into the water. In my fish tank, I have a bubbler that bubbles oxygen into the water. Now, the test for oxygen is a Hatch kit used to determine oxygen concentration. Okay, and so in this case, we're not going to do this one either, because it does take a fair amount of time to do these, and we just don't have that kind of time to do that one. We will do the phosphate test, and we will do the carbon dioxide test as well. So just so you realize, decomposers make oxygen levels decrease. Plants make oxygen level increase. Turbidity increases the amount of oxygen level. High temperature will cause oxygen levels to decrease. Now, why is this a concern? Factories that put out hot water into rivers and lakes, it takes out the oxygen, and that affects the amount of living things that could survive there. And of course, underwater plants make oxygen levels increase. Carbon dioxide present in large amounts indicates a poor water quality. Okay, and so carbon dioxide is a waste gas from living processes. It's also produced as organisms decompose things. Okay, so if there's a lot of CO2, that's a good indicator that there is something wrong with that water source. The test for carbon dioxide is a lime water test. It'll turn cloudy if carbon dioxide is present. If you want to find out the amount of carbon dioxide, because carbon dioxide, when it goes into water, makes an acid, right? Carbonic acid. You could use sodium hydroxide to neutralize it. And then if it uses a lot of sodium hydroxide, that means there's a lot of acidity caused by a lot of carbon dioxide in the water. And we will actually do that in the lab when we get a chance. Okay, most pollutants lower the ability of an environment to support life. So for aquatic environments, this often decreases the amount of dissolved oxygen there. The effect is that the number and variety of organisms in oxygen-poor water has decreased. Now, there are bioindicators that we could use to check whether a water source is clean or polluted. So we could do chemical tests, or we could look at bioindicators. Usually we tend to look at both together. So if water is polluted, you'll tend to find like if you find that there's only carp and catfish, that could indicate it's polluted because they can tolerate high amounts of pollution. However, if you do find that there's trout and perch, they're only found in clean water, so that indicates that the water quality is good. And so here we have a sort of a graph chart, and so here's the clean zone, and there's it gets clean again, and there's a decomposition zone. So in the clean zone, there's trout, perch, bass, lots of different macroinvertebrates. You can see the dissolved oxygen level is high and the demand for oxygen is low. And then what happens in this area here, they're dumping raw sewage in here. So there's lots of stuff for bacteria to break down, so that they use up oxygen. The oxygen level drops and the demand for oxygen skyrockets because bacteria use a lot of oxygen as they decompose. Fish don't use a lot of oxygen. On a grand scale. Okay, and so you can see then the demand goes up, and then as we go on, the demand for oxygen drops, but the oxygen amount drops as well, down to 2 parts per million, which is very low. And so in this area, septic area, you have some of these sludge worms, midge, and mosquito larvae there. Not a lot of different life. The demand is low. And here's some of the trash fish start to show up again. And so the water level, the oxygen level is starting to go up again because everything has been decomposed. Maybe there's some plants that have come in. Maybe the temperature of this water is lower. Maybe there's a white water rafting thing where water is going over rocks. For whatever reason, the oxygen level starts to come back up. And when the oxygen level is up, you get all these macroinvertebrates, and therefore you get the fish that eat those macroinvertebrates there. And you can see the demand for oxygen is low again. And here's the direction of flow of water. So looking at point source versus non-point source, so determining presence is the first step. Next thing we want to do is track the concentration so we could find the source of the pollutants. And there's 2 types of sources of pollutants, point source and non-point source. A point source pollutant, that's a pollutant that enters from specific locations, easy to monitor and control. So literally, you could point at the source. So like drain pipes, smokestacks, those are point source pollutants. The actual exhaust pipe on a car is a point source pollutant. Non-point source pollutants are a pollution where it's released and then it spreads throughout. It's hard to find out where it came from because it's come from so many places and then just gone all over the place. We saw it in the Bill Nye video, right? This is hard to control because the pollutants are dispersed and it's not really a regular release of chemicals. And so like feedlots, golf courses, construction sites, fertilized fields, acid rain. Acid rain's a funny one, right? Because the clouds are up there, and once they're acidified, you can't say where they are, even though originally they came from a point source pollutant, that is smokestacks and car exhaust pipes. But once it's up in the clouds, it's a non-point source pollutant. The funny one, golf course. If you want to change golf course into it is a non-point source pollutant, right? They're burning fossil fuels. They're changing the land. They're diverting water. They're planting non-native species, clearing out other plants that were normally there. There's the fertilizers and the pesticides, and all of these things that come together to make a golf course. If you want to make a golf course a point source pollutant, it'd be kind of funny. You'd have to dome it, and then all the waste comes out of one tube or one pipe. You could actually change it into a point source pollutant. But in general, because the waste goes everywhere, it's non-point source pollutant. These point source pollutants, easy to monitor and control. However, a lot of our pollution comes from non-point source pollutants, and that is a tougher one to try and control. Environmental organizations, both government and private, agree that the cheapest, most effective, and easiest way to deal with pollution is not to make pollution in the first place. We've been trying to do this with the 4Rs: reduce, reuse, recycle, and recover/reclaim. If we can make less pollution in the first place, there's less of it to worry about trying to clean up. Now, the most useful organism for a bioindicator is macroinvertebrates. I mean, we could check for fish, but it takes forever. You have to go fishing, you have to catch a fish. But these organisms here are easy to catch. They're in the mud. All you have to do is scoop it up and sift through it, and you can see what they look like. There's pictures at the bottom of this page. So if the water quality is poor, you're going to find all of these here: the midge larvae, the black fly, pouch, leeches, aquatic worms, and planorbits. They can survive in low oxygen amounts. If you find all of these plus a sow bug and some crane fly larvae, then the water quality is moderate, 4 to 8 parts per million, because all of these are found in moderate quality, but these are found there too, right? It's an inclusive list. If you found that there was black fly larvae and leeches and sow bugs, but then you also found some mayfly larvae, that now indicates that it's good water quality, because good water quality will have all of these, but it'll also have all of these as well. So all you have to do is sift through some mud, and you can actually figure out whether the water quality is good, moderate, or poor based on the organisms that can live there. And I put some pictures on here for some reason. I can't really say why they're there. It's not like I'm going to throw a picture of one of these and say which one is it. This is the end of outcome number 2. Of course, for assignments, you would be checking the assignments on my Google Classroom board. I believe these are the ones we're doing, but to know exactly when we're doing them, you would watch those. And that is the end of outcome 2, so there'll be a quiz coming up, and then we'll be going on to outcome 3 in the next video.